Welcome everyone to Learning with Rev. In this video, we are going to be learning about the functional API in Keras. In previous videos, we made models using the sequential model, and if we look at the sequential model here, we can see that we built a sequential model and we also practice with the model.add in two separate videos. Now we are going to be moving on to the functional API, and we can see all the instructions for this functional API in this Keras web page. You can also see it in the TensorFlow web page. But for now, we are going to be switching over to our Google Colab document here. And in this document, we are going to look over some advantages of the functional API. One, it can handle nonlinear models, such as a recurrent neural network. It also allows for multiple inputs and outputs. For example, if you want to predict the price of a house, you can take inputs of images of that house and also factors such as the zip code. And we can merge that data together and get a result. You could also have multiple outputs. Let's say you want to predict the price of a house, but you don't give the input of the zip code, but you want to also predict the zip code. We can predict those as two separate outputs to the model. Also allows us to train on certain branches of a model and also ignore different branches. So we can train the price branch first, then we can freeze those layers, and then we can train the location branch without adjusting the weights or the biases of those other branches. So just as we begin any neural network, any programming in Python, we are going to be loading up all of our TensorFlow and NumPy packages here. We're also going to load and pre-process our MNIST data. If you don't know what this is, you can just hop over to this video I'm linking in the top right, and it will show you what MNIST is, what the data looks like, and why we load it in the way we do. So, how do we build a model? Similar to the sequential API, we start off with an input. So I'm going to say input equals input, which is a function in Keras, and we're going to set the shape equal to our input shape. And that input shape is declared right here, 28 by 28 by 1. That means our images are 28 by 28 with one color dimension. So, unlike the sequential model, we can now make another layer, whatever we want to call it here. We can conv2d. We have 32 nodes within there with a kernel size equal to 3 and 3, and activation equals ReLU. So just to review what all that means, first of all, we have our 32 is the number of nodes in that layer. Next is our kernel size for that convolution, which is how big is that filter that slides over the image. And then activation of ReLU, not ReLI, is going to be our mathematical activation on that node of the data that's getting passed through, of the weight. And to attach the previous layer to it, we just put it in parentheses right next to it. So now we can set x again equals to max pooling 2D, with a pool size of 2 by 2. And we can also set x there. So x initially equals this convolutional layer plus the input layer. And then we set x again equal to this max pooling layer on top of what x previously was. So it's a great way to build your model. You can set, if you're making it linear, just name everything the same thing and it'll just overwrite what that variable means every single time. Next, we're going to set another convolutional layer with 32 nodes this time with a kernel size of 4 by 4. So a slightly different kernel size, a little larger, probably too large for this image size, but that's okay. We're not making the first model, we're just showing how to build one. Next is one more max pooling layer within, not input shape, we want a pool size of 2 by 2. And we want X there again. And now finally, we are finishing off our network with a flatten layer. X equals flatten. No, nothing is passed into it. So now whatever size this data is, it's now all in one dimension. And that allows us to do an X equals dense with 10 nodes with activation of softmax. So now we have to set our model equal to big letter M model, which is also a Keras function. And inside this function, we set input equal to our input and our output equal to X. And we'll see what happens here. We want inputs and outputs. Oh, what is going on here? Oh, X here did not continue on from there. There we go, and our model is built. We can show this off here with our model.summary. And that builds a summary of our model and also our input. So we have our input layer, convolutional, max pooling, flatten, and dense. And just like before, we can train this model and it is off training. So this was a quick lesson on what the functional API is. Instead of doing model.add or building it within a list within the sequential function, we build it layer by layer, and after each one, you just grab that previous layer name that you want it to extend from. And at the end, you wrap it in model, you set your inputs and your outputs. It's great if you're ever going to do an autoencoder or any multi-dimensional non-linear model. And we can show right here, this one is linear. And in our next video, I will be showing everyone how to build a non-linear model with the functional API. Thank you all for watching. I hope you learned something today. If you liked it, please give it a thumbs up, share it, and if you have any questions, please leave them in the comments. So again, thank you all for watching, and I'll see you next time.